go.
You remember what app she uses?
All right. Hello, Emma. We are in section 1.3. We're starting notes for properties of real numbers. We have 9 examples. We'll see if we do all of them. I don't know. I might skip over a couple of them if we're doing real good. We'll see. We'll see. We'll see. Okay. All right. So properties of real numbers. Here we go. We've got some things and we've got some vocabulary words and all the things right here. So they don't outline these very well. I'm going to put numbers next to these. The reflexive property. The reflexive property. You guys will not use the reflexive property so much in this class, but we use it in geometry for specific purposes, like for proofs and stuff, okay? But here's what the reflexive property says. It's kind of a dum-dum, right? It says like 3 plus 2 will be the same thing as 3 plus 2. It's like the same on both sides, right? That kind of seems silly. The reflexive property. Something is the same as itself.
Common sense.
Yeah, it's common sense. The way that we use this in geometry. Here's how we use this in geometry. Ready? I'll give you the example. All right, let's say I have these 2 triangles that are touching each other, right? And let's say this is A. You don't have to write this down. Don't write this down. A, B, C, D, right? I'm trying to show that this triangle is the same as this triangle, yeah? But what I'm going to do is I'm going to dissect the sides, and I'm going to say BC, which is this side, is congruent to BC. But what I'm saying is BC for this triangle is the same length as BC for this triangle. So even though it's the same BC, it's 2 different BCs. Does that make sense? Yeah. That's an application of when we use the reflexive property. You guys won't use it very much in Algebra 1. But it's there. Okay, the next one is the symmetric property. This is number 2. And here's what the symmetric property says. I don't like their example. I'm going to write my own example. And it is 2 equals x.
Okay.
Okay.
So variables equal numbers.
X equals 2. That's what the symmetric property says.
Oh.
If you're one of those people that are like, I don't like 2 equals x, I'd rather have the x on the left and the number on the right, the symmetric property is what allows you to do that. Symmetric means symmetry. Symmetry means the same on both sides. So I can flip them back and forth and it will be the same. Right? Does that make sense? Okay. Or are you like an I like x equals 2 and not 2 equals x people? Same. I like to have my variable on the left. Okay. All right. The transitive property. Transitive means transition. And the transitive property means this. This is number 3. Here's what the transitive property means. Are you ready? If x equals 2 and 2 equals y, then
X and Y equal each other.
x equals y, right? It's kind of like the middle 2 pieces cancel out, okay? We do this in geometry where I say, let me talk about like, who's my old people in here? Old, you're old? Who's my young people in here? Lane is young? You're young? Who's my medium people in here? Cole? Okay, so Kaylin is older than Cole, and Cole is older than Lane. Is that true? Kaylin is older than Cole. Cole is older than Lane. So Kaylin is older than Lane. Does that make sense? She's older than Cole. Cole is older than Lane. So Kaylin is older than Lane. Right? I can go from the first piece to the second piece to the third piece, so I can go straight from the first to the third piece. Right? Does that make sense? Okay. That is the transitive property. I can transition them around and have that relationship. Got it? Woo! All right. Identify the property that we have going on here. So if 13 plus 25 equals 38, then 38 equals 13 plus 25. I've taken and swapped these 2 around. Which property is that? Symmetric. The symmetric property. S-Y-M-M-E-T-R-I-C. The symmetric property, which means it's the same on both sides. I can flip them around, right?
We just put like S-Y-M.
Sure. I'm all about the abbreviations. Unless you have another one that starts with S-Y-M, then give me a couple more, but S-Y-M is the only one. Okay, what about B? Y plus 4 equals Y plus 4.
That would be the
The reflexive property. The reflexive property. If you want to be like just REF, that's totally fine. Reflexive property. I'm all about the shorthand here. Good? Happy with that? Example 2. If the amount of sugar in a recipe is equal to the amount of flour plus 2 tablespoons. Okay, stop. Amount of sugar is equal to flour plus 2 tablespoons. Sugar is equal to
F plus 2.
flour plus 2. Now I don't have to go back to that sentence. I'm good to go. And the amount of flour plus 2 tablespoons is equal to the amount of milk. The amount of flour plus 2 tablespoons is equal to The amount of milk.
So that means S equals
Then that means the amount of sugar is equal to the amount of milk, and that is the transitive property. Okay, we did that all up here. I don't know. I should have put that in here. S equals F plus 2. You don't have to rewrite this. F plus 2 equals M, then S equals M. That's probably what they wanted to put in those boxes. And then part B says this is the example of the transitive property of equality. Happy with that? It's just a story problem that, like, you know, is kind of confusing. Yeah. Okay? Number 3. Use the given property of equality to complete each statement. If we're doing the reflexive property, that means it's the same as itself, right?
Yeah.
So if I have y minus 2, on this side it has to be
Y minus 21.
what? I said 2, not 21. You're right. Y minus 21. That is the reflexive property, so that's what should go in that blank. Got it? All right, now they want us to use the transitive property to answer the question. So 24 plus 11 equals 9 plus 26. 9 plus 26 equals Z. So it's like I have part 1 is equal to part 2. Part 2 is equal to part 3.
26.
So this guy is equal to part 3. I'm skipping from 1 to 3, right? 24 plus 11 is equal to
6.
Z.
What did you say?
Where'd you get 6?
I said 26.
No.
Um,
This guy's equal to 9 plus 26. 9 plus 26 is equal to Z. So this guy's equal to Z.
oh yeah.
Yeah, yeah?
So it'd be everything is
That's the transitive property. Yeah, yeah. Very nice. Okay, good. I'm going super fast. Am I going too fast?
no.
No, I'm good.
Mr. Boniface over there is going to be lost no matter what. So it doesn't matter how fast we go. Oh, man. All right. Now we've got inverses and such. Okay. So the additive identity. Circle the words additive identity. Okay. Identity means the same. So if I'm talking about the additive identity, there is one number that I can add to any number and it stays the same number.
0.
If you add 0 to any number, the additive identity is 0. The additive identity itself is 0, right? I add 0 to any number. 0 plus 17 is 17. 0 plus 24 is 24. 0 plus 103 is 103, right? And the additive identity is 0 because I add 0 to anything and it stays the same number. Got it? Okay, the additive inverse, circle that. The additive inverse. Inverse means undo, right? So if I have the number 4 and I want to undo the number 4 to get back to 0, what undoes 4 to get back to 0?
4.
Subtracting 4. If I'm like adding a negative 4 basically, I will get back to 0, right? What's the additive inverse of negative 7?
7.
Positive 7. Those two are additive inverses, right? Because when I combine them, I end up getting 0, okay? So the additive inverse. Now, this is a little bit confusing because the additive identity is always 0. The additive identity is always 0. 0 is the additive identity, but the additive inverse will change depending on what your number is. Does that make sense? It's the inverse of whatever number you have, right? Okay? Additive identity is always going to be 0, right? But the additive inverse will change depending on what number you're starting with and you're trying to undo, right? Does that make sense? Clear as mud? Okay. All right. Okay. He's even shaking his head like, yeah, I know what you're talking about. Okay. Okay. Now we have the multiplicative identity. Blah blah blah. Say that word. Multiplicative. Blah, blah, blah. How many syllables is that even? Multiplicative. 5?
Something like that.
5? Multiplicative. Blah, blah, now I can't even say it. Okay. The multiplicative identity is a specific number. And it is the number that you can multiply by any other number and keep it the same.
1.
1. The multiplicative identity is 1. The additive identity is 0. The multiplicative identity is 1 because anything times 1 is that same thing again, right? Like 4 times 1 is 4. 7 times 1 is 7. 1 times 103 is 103. It stays the same, right?
I thought it was always called the identity property of multiplication.
I think they're the same thing. They just make it like fancy. They make it a 5-syllable thing. I don't know.
No one could say.
That nobody could say. So they probably called it that for a reason because, like, 7th graders, multiplicative is too sophisticated of a word for 7th grader. But now that we're big kids, multiplicative, we can deal with that, right? Okay. All right, now this one is the multiplicative property of 0, okay? Because what happens when you take anything times 0?
Zero.
Is 0. So 7 times 0 is 0. 0 times 104 is 0. I'm sorry. What if I take 0 times negative 2?
Zero.
It's negative 0, but it's 0, right?
Zero.
Negative 0 is still 0.
Not positive or negative.
Right. So it's still, yeah. It's technically negative 0, but that's just 0, right? Okay? All right, and the last one is the multiplicative inverse, okay? The multiplicative identity is always a number, and that number is 1. But the multiplicative inverse will depend on what the number is, kind of like the additive inverse will depend on what that number is. So if I'm dealing with 1/2, what do I have to take times 1/2 to get back to 1? 2 over 1 or just 2, right? Okay? And the way that works is that, like they cancel, right? Did you know that? Okay? Like the top numbers cancel, the bottom numbers cancel. Okay, let's say I'm talking about 7/2. What do you have to take times 7/2 to get back to 1? 2/7, right? Because those cancel, right? The top and the bottom. Okay, now, what if I have negative 8?
No.
Ooh.
8 over 1.
This is 8 over 1, right? If I make them into a fraction, right? So what do I have to multiply by 8 over 1? 1/8 is a positive or negative?
One negative 8.
Yeah, 2 negatives makes a positive, so it has to stay negative 1/8. Okay? Now, I heard a lot of you say 1 over negative 8. That's the same thing as putting the negative on the outside here. True? Did you know that? Negative 1/8. So you can either put the negative in the bottom or you can put the negative out front. It doesn't matter. But what you can't do is put a negative here and a negative there, right? So you don't have to write this down, but follow along. Here we go. Let's say I have negative 1/8. That's the same thing as 1 over negative 8, which is the same thing as negative 1/8 out in front, but it's not the same thing as negative 1 over negative 8. Right? You can put it in the top, you can put it in the bottom, or you can put it on the side. But why can't you do this?
That turned into a positive.
Because a negative divided by a negative, I think I heard Ethan say, Ethan? You go by Ethan, right? I heard him say
It's positive. You can't have
that 2 negatives make a positive, right? So those will cancel out and that makes a positive. So that's not the same, right? Yeah? Okay, beautiful. Happy with that? So the multiplicative inverse is what undoes the fraction or whatever to get back to 1, okay? All right, evaluate using additive properties. Here we go. How many terms are in this thing? 3. 1, 2, 3. Because what separates terms?
multiplication and addition.
Addition, subtraction. Woo! Because this is multiplication, right?
Yeah.
And that's only one term, right? Okay. So let's simplify each individual term to get them the same currency like I talked about yesterday, right? We want everything all in inches, right? And then we can add them together. So 4 is just going to chill. He's fine. 4 is chilling. Minus, what's 2 squared? 4. What's 8 times 2?
8 times 6.
16. Okay, now I can put them all together. What's 4 minus 4? 0. I'm going to cross them off. So the final answer is 16. Final answer. They do weird things, so I don't like go by some of their work all the time. Okay? Good?
Yep.
Woo! All right, that was a lot already. Okay, example 5. Oh, do we have to write what property that was? No. Okay, this one. Evaluate 3/2 times 2/3.
That'd be that they cross that.
They cross each other out because 3/2 and 3/2 and 2/3 are what? 1, because they are multiplicative inverses, right? So now I have 1 times 7, which is, actually I should just write it here. 1 times 7 is 7, final answer. They are multiplicative inverses. They cancel each other off, right? Because they end up being 1. Got it? Am I going too fast? Okay, all right. 6, example 6. Okay, all right, we've got a parenthesis here, basically. This is like a parenthesis, even though it's a bracket, right? How many terms are inside that parenthesis? 1, 2, 3. There's a minus and a plus. But 3 times 2, I have to make him 6 first. 4 minus 6. I'll write this out. 4 minus 6 plus 7. 4 minus 6 is negative 2 plus 7 is
No, it doesn't matter. It's times
5. But it doesn't matter because it's times 0 at the end, so it is 0. That uses the multiplicative identity because anything times 0 stays 0, right?
What was the multiplicative?
So,
No, the multiplicative identity was the one with the 1. This one's the power of 0.
no. Multiplicative inverse is 1. Multiplicative identity.
Yeah, this is the multiplicative property of 0.
Oh, yes, you're right. Multiplicative property of 0. I lie. So, if you identified that to begin with and saw that everything was times 0, you could just like not even worry about this and say, I don't care about what that is. I don't care even about what that number is. It's take the times 0, you know it's going to be 0, right? It'll save you time. True. Like, you have to be careful. But, like, the way that it's set up right now, that whole parentheses, whatever that number is, we don't care because it's multiplied by 0. If it was a different scenario, we'd have to be careful, right? Okay, that was example 6. Woo! This is a lot. Holy moly, we got more properties. Okay, two more properties, I think. Is that it? Yeah, 2 more properties and that's it. So we got 2 on this side, 1 and 2. The associative property. Okay, do you know what the word associate means? Who do you associate yourself with? Like at lunch, who do you sit with? Your friends, right? Okay? And maybe in certain classes you associate yourself with this group of kids, but then in a different class you have different friends that are in that class who associate with this group of friends, right? So here's what happens. The associative property only works for addition and multiplication. It does not work for division and subtraction. You cannot associate division and subtraction. I'll show you that here in a second. So what I mean by the associative property, let's say I took 2 plus 3 and I add 4. That's going to be the same as 2 plus 3 plus 4. The parentheses mean that's what I do first, right? So over here I get 2 plus 3 is 5 and 5 plus 4 is 9. Over here, if I add 3 plus 4 first, that's 7. And is 7 plus 2 also 9? So it doesn't matter what order I add them in. True?
It's gonna be the same.
It's going to be the same. So I can add them in any order, right? Yeah?
Yep.
Okay, for multiplication. Let's say I have 2 times 3, and then I multiply by 4 versus 2 times 3 times 4. Here I'm multiplying the 2 and the 3 first, which is 6, and 6 times 4 is 24. Here I'm doing 3 times 4, which is 12, and 12 times 2 is 24. So I can associate those in different orders, and no matter what, it will be the same, right? That is not true for division and subtraction. It does not work that way.
Isn't this just commutative property with parentheses?
No. Commutative properties switching the order around, like this way, kind of. They're similar to each other, right? So the commutative property says this. If I take, and this again is only for addition and multiplication, not for subtraction and division, right? Commutative property means they can commute. What does it mean to commute? Like if you commute to school, you're traveling to school, right? You can travel and do certain things, okay? So example of addition would be like 2 plus 3 is the same thing as 3 plus 2. I can flip them around and it doesn't matter which order I like go in, right? Same thing with 2 times 3 is the same thing as 3 times 2, okay? What is not true is 2 minus 3 is not the same thing as 3 minus 2, true? One of them is positive 1, one of them is negative 1, yeah? Okay, same thing with 4 divided by 2 is not the same thing as 2 divided by 4, right? One of them is 2, the other one is 1/2, right? So the commutative property does not work for multiplication, or excuse me, subtraction, division, but it does work for addition, multiplication. Did I say that wrong? Subtraction, division doesn't work. Multiply, add does work, yeah? Okay, all right, let's go down and let's do an example. Jalen wants to add up how much money he spent on gasoline in July. He grabs the 4 receipts he has for July and writes the expression that represents the total amount he spent. Evaluate the expression to determine how much money he spent on gasoline in July. All right. There is that. We've got all of these. You just add them. Doesn't matter what order you add them in first.
No.
So, like, if I grab these receipts out of my purse or something, do they have to be in order in which I went to the store, right?
No.
Could I do the last store first? It doesn't matter what order I add them in, right? Okay, so I just add them up. I would use a calculator if I were you. I would not try to add this on my own because that would take too long. Okay, there's some times where I use a calculator. Sometimes I'm like, nope, I can do this faster in my head. Spent how much money? How much? Does Cole have an answer?
No, not yet.
No, yet?
1.6.
What?
1.2.
Exactly?
Yes.
Woo!
Crazy how that works out.
122, that'll fill up my tank like
1.
1.5 times.
Yeah, there's no way you spent the.
Because I have like a 27-gallon tank, something like that, and gas is way too expensive now. I guess. Or they have like a small tank. They're a car. So cars sometimes will only hold like, I don't know, 15 gallons or something like that. I hold almost double that. So, I don't know. And maybe they don't wait till it gets to E like I do.
Maybe
I wait till we're on empty. Like my car is like, beep, you need gas before I get gas. And it drives my husband crazy. Yeah, you have to have 50 miles left. Oh, I can make it to school and back on 50 miles. My husband like kills me. All right, example 8. Here we go. We are multiplying. Oh my gosh. In its fractions. Oh.
That cross out that.
So what do? We know from which property the commutative or the associative property kind of is the same as commutative a little bit, that I can bump this over here and I can do 5/6 times 6/5 and then times 9, right? And we know that those cancel out and they make 1, right? And then I have 1 times 9, which is 9. Final answer. Okay? But don't look at those fractions and say like, oh crap, we got a fraction. It's fine. It's fine. Okay? 9. Jade buys groceries once a week and she wants to calculate how much she spent on groceries. Oh man, I wish. Oh, I wish. $32 on groceries. Oh, that will buy like a sack of grapes.
$28 on groceries. 27.
Evaluate the expression to find how much Jade spent at the grocery store. What do?
You just write it and
Add them all together, right?
It's $120.
It's $120.
Yeah.
Okay. I think what they were wanting to do, here we go. I see this. I get what they're wanting to do. Okay? If we look at these numbers, I know that something that ends in a 2 and something that ends in an 8 will end up being 10, right? So if I add these two together, what's 32 and 28 make? 60, right? Okay? But then also 7 and 3 go together really nicely, right? So if I add those together, that's 60, and that is something that you can do in your head, right? Okay? So 120 is the total, right? That's kind of what they were, I think, getting at, right? Try to like put them in a different order so it's easier to add them, right? Good, good?
Good.
Okay, I don't have your homework assignment written down. Identify the property. Let's see what we got.
Are we going with 4?
Can we go by 5?
Yeah, 5. What about 10?
No, you are silly.
Why can't we go by 5? I guess we don't have
Let's go 2 through 30 evens. That's only 15 problems. Can we do that? 2 through 30 evens, maybe? Page 31. 2 through 30 evens.
Why not all?
All evens. 2, 4, 6, 8, 10. What? You don't have the one that gives it to you? Oh, yeah, because we ripped it out. But it doesn't matter. It's fine. It's fine.
30? Oh.
Only to 30. So it's only one page.
Only one.
So you can rip out the second page and throw it in the
Garbage.
or recycling.
Fridge?
I don't know who's in charge of like the recycling, like what kids are doing that, but I desperately need my recycling like emptied. Yeah, I do. It's over there. But it's very, very much full. So, all right, goodbye, Emma.